Hello and welcome to the tutorial on MQ triggering. In this video, we are going to show how to use MQ triggering to start channels. Also, we are going to show how to start processes through MQ triggering. We will see how to create trigger monitor process and set up triggering. I am going to log on to the Mint Linux server. Then, I will switch to the MQM admin user. Going to set up MQ environment using setmqenv command. Let's see the status of the queue manager using display MQ command. Going to start the queue manager lintest1 using start MQ command. I am going to create a second queue manager lintest2. Then I will create sender-receiver channels from lintest1 to lintest2. This will be followed by another set of sender-receiver channels from lintest2 to 1. We will see how to enable the automatic startup of sender channel using channel triggering. Also, we will see how to create trigger monitor and use it to process the request message from lintest1, and then produce the response message from lintest2 to 1. Now, let me display the listeners defined at lintest1 queue manager. That shows a default system listener and another one that we have previously created. We are going to use only the listener that we created for lintest1. Let us show the status of the listener. And it shows that the listener is running. Let us also see the parameters of the listener.
An MQ listener is a process that listens for connections to the queue manager. Each listener object in IBM MQ Explorer represents a listener process. But, if you start a listener process from the command line, the listener is not represented by a listener object in IBM MQ Explorer.
The following footage shows how the listener was created earlier. Using the define listener MQSC command with run MQSC. Control QMGR indicates that the listener will start when the queue manager starts. Port keyword provides the TCP port to be used for listening. Use run MQSC with our listener script to create the listener. Afterwards, start the listener using start listener MQSC command. Now, let me create the second queue manager. Using create MQ lintest2 command. To start the queue manager, use strmqm command. Also, I am going to create the listener for the second queue manager lintest2. Now, let us develop the MQSC scripts required for creating MQ objects on both queue managers lintest1 and 2. lintest1_basic.mqs contains definitions for queue manager lintest1. lintest2.basic.mqs contains definitions for lintest2. Let us take a closer look at the scripts. First, let us see the definitions for lintest1. The define queue local DLQ line creates the dead letter queue. Next line associates DLQ with queue manager as default. Next line creates the transmission queue for sender channel. Define QR line creates the remote queue for the request queue at the other side. Define channel QM1 to QM2 creates the sender channel from lintest1 to lintest2. The next define channel line is for the receiver channel QM2 to QM1. The last line is for the queue which receives reply messages from lintest2 to lintest1 through receiver channel QM2 to QM1. This is temporarily defined as a model queue, but we will update it later after showing the use of dead letter queue. Let us run the script using run MQSC command. First test for syntax with -v option and then execute the script to create the MQ objects. Let us now look at the script for the second queue manager lintest2. Top two lines define dead letter queue and associate it as queue manager's default. Next line defines the transmission queue for sender channel from lintest2 to 1. Next one is for the init queue associated with the trigger monitor. Next four lines are for the request queue. Next two definitions are for the reply queues. there is a remote queue to send the reply to lintest1 and an alias queue corresponds to this remote queue. The defined channel QM2 to QM1 is for the sender channel from lintest2 to 1. The next defined channel command is for creating the receiver channel QM1 to QM2. Let us ignore the commands for the process commands for now, because we will see how to create the processes through MQ Explorer later. I am going to remove the trigger parameters from the request queue temporarily. It will be enabled later. Let us check for the syntax and execute the script for lintest2. That shows us that the MQ objects were created successfully. To view the MQ objects, let me log in as MQM user through Xterminal. The MQ Explorer shows the two queue managers lintest1 and 2. Expand lintest1 to see the MQ queues and channels. Similarly, expand lintest2 to view the MQ objects. The status of channels on both queue manager shows as inactive. Let us take a look at the transmission queue of sender channel QM1 to 2 and set up channel triggering. Click on triggering and set trigger control to be on. Trigger type is set to be first and trigger depth is 1. This means that when the first message arrives at the request queue, triggering takes action. For the initiation queue, select the system.default.init queue. And for the trigger data, enter the name of the sender channel. Click Apply. In the same way, enable channel triggering of the other sender channel QM2 to QM1. By updating the trigger parameters of transmission queue at lintest2. Now, let us test the channel QM1 to QM2 by putting a message on the request queue. Let's look at the channel status to see if it is running. It is running. Note that the corresponding receiver channel is also running at lintest2. Let's also check the destination request queue at lintest2 to see if the message arrived from lintest1. It has arrived. Let's now test the channel QM2 to QM1. The input queue for this channel is the alias QQL.reply, which points to the remote QQ_QM.reply. Let's put a message on the alias QQL.reply. It should start the sender and receiver channels QM2 to QM1 at both queue managers and transfer the message to lintest1. The channels have been started and running. But, where is my message? I don't see the message at the reply QQL.reply. Let's see further. I see a message at the dead letter Q. Let's browse the message and look at the contents of the message. Yes, it is the same message that we sent from QM2 to QM1. It was sent to DLQ because the queue that we defined is a model queue and not a local queue. So, I am going to delete the model queue and recreate it as a local queue with the same name QM.reply. Now, let us test again by putting another test message. Look for the second test message at lintest1. And check if it reached the reply queue instead of DLQ. Yeah. We received the message at the reply queue and it is the same second message that we sent. So we have verified that the channels are working good both ways. At lintest2, let us create an MQ process based on a simple shell script, and associate it with the trigger monitor, which is supposed to process the request messages originating from lintest1. This MQ process will create the reply message and send it back to lintest1. I create a simple shell script called testunload.sh. This script uses dump MQ message command to unload the messages from request queue to a file. Next two lines create a response message and put that message to the reply queue using a mqs_put_sample command. Let's also create an alias queue for the request QQL.req. Now, we are going to create an MQ process with the test unload script at lintest2. Right-click Process Definition, click New and then select Process Definition. Enter the process name, then click Next. Enter the name of the test unload script with the full path. Enter ampersand under environment data. This is for making it run as a background process. Click Finish. Then make sure to update the process name at the triggering tab of the request queue ql.init queue. After that, click Apply. Note that the initiation queue is set to ql.init queue. This is for sending the trigger initiation message to init queue, which will be processed by the trigger monitor. Now, let us start the trigger monitor process on Queue Manager lintest2. Leave that terminal window as it is. Let us test our setup by putting a test message at alias queueRequest.queue at lintest1 using AMQS put. Enter test messages. After 1 or 2 seconds we see a message at the reply queue qm.reply. Let us take a look at the trigger monitor console window. It shows that our test unload script got executed. We can see the outputs from the dump MQ message command as well as the AMQS put command. Let us take a look at the reply message that was received at qm.replyqueue at lintest1. And see if the message is what we expect from the test unload script. Yes, this is what we expected. Also, let us open the test unload script, and check the contents of other files created by it. The request message dump file shows the dump of the message from the request queue. Using dump MQ message command, we will load the message from this file to another test queue. That way, we can verify if this is the same message sent from lintest1. That command gave an error 2085 because test queue2 is not available at lintest2. But it is available at lintest1. So let us again run the same command against Queue Manager lintest1. This time it went good. Test queue2 had already an old message. The new message updated the queue depth to 2. Let us examine the latest message. Yes, indeed it is the same message that was sent from the request queue. To summarize, we have created two sets of channels in opposite directions. Set up channel triggering, set up process triggering using trigger monitor. And used it to send request messages from Queue Manager 1 to Queue Manager 2. Process the message at Queue Manager 2 and then send reply messages from Queue Manager 2 to Queue Manager 1. Thank you for watching.